Hi there! Did you know that using a wrong keyword can make a significant impact on the performance of your application in C#? Today, we're diving into the differences between synchronous and asynchronous code in C#, and the differences are plenty. Greetings, dear friends, fellow programmers, and those aspiring to be. Welcome back to Marko Code Academy, a place where we synchronously learn about asynchronous code. Alright, let us set the stage. Synchronous and asynchronous programming are the two pillars of modern software development in C#. If you are building an application that is supposed to be responsive and performing well, understanding these two core concepts is a must. So, in this video, we will be breaking down what are the main traits of both of these approaches and basically when you should use one or the other. First, let us talk about the challenges that developers are facing when choosing between synchronous and asynchronous approach to solving a problem. Imagine the following scenario. You're entering a busy restaurant, and the chef can only manage a single customer at a time. A new customer enters the restaurant, they stand in line, and when they get their chance to order, they say what they want for food and drinks, and then the chef has to prepare everything and give it to the customer, and only then be able to serve the next customer. This approach is synchronous, and it completely relates to synchronous code, meaning that one statement has to be completed and then we can proceed to the next one. Of course, this approach is very simple to understand, debug, and go through in general, because it's very simple. But, on the other hand, it is very easy to stumble upon problems when using it, because you can completely block off your application and prevent it from being able to do anything and to be completely frozen. That is because each task, the same way as each customer, has to wait for its turn in order to be served. And that can take a while sometimes. Now, let us imagine the alternative approach, which is you still have the same restaurant with many people waiting in line, but the chef doesn't work on cooking the entire dish before they get started with the next customer. When the customer arrives, gives chef the order, and then chef starts preparing the order from the customer, and when everything is set and cooking, they proceed to the next customer, hear the next order, and then prepare the next order. And of course, at any point when the order is ready for any of the previous customers, chef will handle it and give it to the customer whose order was ready. So now, when we translate this into programming terms, that means that when you're using asynchronous code, your code can be executed multiple tasks at a time, at the same time basically, and the tasks will be performed by different threads, meaning that you can execute multiple actions in parallel and allow your code to be way more performant in the end. In C#, when you're using synchronous code, everything has to be executed sequentially, meaning that in this example I have prepared for you, you have three method calls that have to be executed one at a time, meaning that cook main dish is going to be executed first, and before it is done executing, the next method, which is bake desserts, cannot start executing. And when the first one is done executing, the bake dessert is going to get started, and when it is done, then prepare salad is going to get started as well. Meaning that you cannot go out of the flow of execution. Everything has to be executed sequentially. While this code is definitely easier to understand and navigate and also debug, it can also bring up a lot of inefficiencies. Just imagine the scenario that bake dessert is a very slow method that takes maybe 2, 3, 5 minutes, and you would just have to wait for that method to execute completely and then be able to proceed to the next one, which is prepare salad. That would end up being a very poor user experience if your customers had to sit and look at the loading screen while your dessert was being prepared for extended period of time. In contrast, when you are utilizing asynchronous programming in C#, you will be able to execute multiple things at the same time concurrently, meaning that in this example I have prepared for you, you can see that we have async await keywords showing up. And what this means is basically we have initialized and initiated the execution of our 3 methods, which are basically the same methods as before. Just this time they're tasks, which is going to wait for all 3 methods to be done. But the execution doesn't have to be done in the same order in which we listed the methods. Maybe bake dessert takes much longer than the other 2 methods, meaning that those 2 will be done first, and then over some time bake dessert will be done as well, and you will be able to continue working with all the results. But what is most important is that all 3 methods will start their execution practically at the same time. They will not wait for the previous method to be done executing before the next one can start. And of course, when you think about it, this approach is very powerful whenever you are working with slow actions like I/O operations or networking or API requests or anything like that. Basically, whenever you need to wait for something for a significant amount of time in the world of programming, which can still be milliseconds, but still you definitely do not want to block your main UI thread from being able to handle user inputs, from preventing users to interact with your application, because it will be a very poor user experience. To truly understand how C# handles synchronous and asynchronous code, we must look under the hood. We need to see those gears moving, and that is the only way how we can understand what is actually happening when we write some asynchronous code or when we write some synchronous code. So get yourself ready to find out how .NET Runtime handles different programming approaches. I hope you're going to feel like you're stepping into the control room where all the controls for executing our code are being stored. In synchronous execution, we have the following scenario. You have a data structure called call stack. This data structure accepts all the things that need to be executed and pushes them on top of the call stack. And then, one at a time, are being executed. But you can only execute one thing at a time, meaning that you can observe it like a stack of plates, and then each plate is added on top. And here, each plate is basically one operation, meaning that when you call some method, it is pushed to the call stack, and before it is done executing, the next method cannot get started executing. And basically, this is what makes synchronous code so simple to understand and navigate in our code. Because you always go linearly and you always know that just a single thing can be executed at a time. Basically, in our previous example for synchronous code, we can see that our cook main dish is being thrown to the call stack first, and until it is done executing, the next method, which is prepare desserts, cannot be executed at all. And then we wait for the prepare desserts to be done, and then finally we can prepare the salad. When we use synchronous code, there is one most significant issue that arises, and that is thread blocking. When you start executing something, in our case one of the 3 methods, it completely blocks the main thread for our application from being able to handle anything else. Meaning that your application will be frozen and it will not be able to comply with your requests, to handle your interactions, to allow you to execute anything basically before the current action that is executing is done executing, which of course ends up meaning that your application will be able to handle way less requests at a time. Asynchronous programming in C# works differently, of course. It doesn't rely on the call stack, it utilizes something new. We call it task-based asynchronous pattern, or TAP for short, and it leverages event-driven architecture. At the heart of asynchronous programming lies event loop. When you call an asynchronous method, it doesn't get pushed to the call stack and block the main thread. It gets converted into a task, which you can observe like something like promise. Promise that this task will be executed a bit later. And then these tasks that we have created are being handed over to the event loop, and then event loop decides at which moment each task will be assigned resources that will allow it to get executed. And when I say resources, I basically mean a thread on which this task can be completed and all the business logic inside of it can be executed, whether it's reading a file or sending a request or whatever. And then the magic happens. Event loop doesn't block the main thread. It keeps checking whether the task is complete. It does it repeatedly, all until the task manages to complete its execution and it is ready to basically say to the rest of the application that it has the results that we are waiting for. And at that point, event loop will pass that completed task further on to the execution, meaning that the code is going to keep going from where it left off. And then there is the underlying mechanism that is basically a state machine that will take a snapshot of the situation before the task started executing, and then when it is done, the state machine will return the state as it was before the task started executing. And then it continues, of course. In applications with user interface, there is another significant part to the whole mechanism, and it is called synchronization context. The main job of this context is to make sure that when task is abated and it is done with all the calculations and it has the result of its execution ready, and then the context makes sure that the task continues executing on the correct thread, which is usually UI thread. It basically means that synchronization context will remember from which thread a certain task started executing, and when it is done executing, it will know to which thread it should continue the execution of that task from. Of course, this prevents issues like updating from a non-UI thread. As I already mentioned, when we use a wait keyword in our code, something amazing happens, and that is that a new state machine gets created, and its main purpose, or its only purpose, is to make a snapshot of the current state of the method that we are invoking. What this means essentially is that when we are running a method that inside of it contains some asynchronous tasks that need to be executed, our application or our method is going to be executed one line at a time, and then when it reaches the await line that we just mentioned, it will stop the execution there, it will pick up the task and throw it to event loop to make sure that it gets executed and handled properly, but it also instantiates a new state machine that will make a snapshot of everything that is going on in that method, so that when the task is done executing and we do have the result of that task, the state machine will recreate all the previous things that were happening in the method and allow us to continue execution from that point on. This process allows us not to block threads in our application because our UI thread will be offloaded. It will not be responsible for handling those asynchronous tasks, but also the state machine will allow us developers to have a feeling that the code gets executed almost sequentially, which is very important for us people because asynchronous code without these kinds of mechanisms would be terribly difficult to follow and understand. Because actually, when you think about it, your code is constantly being delegated to different threads, which are being executed in different times, and you receive the results and then they get executed completely, then you get another result, then it gets executed, and it's complete mess. It's very difficult for us people to follow the flow of things when it is working with asynchronous code. But state machine makes it easier to follow. So, why do we go through all of this complexity in the end? Well, as you already know, it is done because we do not want to block our UI or main thread of the application. And by doing that, we will improve the user experience for people using our application significantly, because they will not have to wait for extensive periods of time when we are loading a file into memory or when we are sending requests with a lot of payload or something like that. We would make a smooth experience and our application would be completely able to handle all the interactions from users, while also asynchronously at the same time handling additional operations. Just imagine the scenario where you have a server that's serving hundreds of thousands of people at the same time, and each user has to wait for other users' actions to be completed sequentially before their action can be executed, because the server would be using synchronous code and it would go one request at a time. That would end up being a terrible user experience. So when we use asynchronous code, our server can handle multiple requests from multiple people at the same time and everybody would be satisfied. So to wrap things up, in this video, we managed to learn what are the key differences between synchronous and asynchronous code in C# and some of the basic underlying concepts and mechanisms that allow these behaviors to take place. Before you go, of course, I would love to hear your experiences and your take on the synchronous and asynchronous code in C# and leave it in the comment section below. And if you would like to learn more about C# best practices and how things work under the hood, please feel free to subscribe to the channel and turn the notifications on. Until the next video, thank you for watching and have an amazing day. Bye.